Download this code from codegive.com, link in the description below. Jmeter Tutorial 22, Mastering Timers for Realistic Load Simulation. In the world of load testing, simply bombarding a server with requests isn't always the most effective strategy. Real users don't fire requests at a constant, unrelenting pace. They pause to read content, think, and interact with elements on the page. That's where timers in Jmeter come into play. Timers introduce realistic delays between requests, simulating more natural user behavior and providing a more accurate representation of real-world load. This tutorial will dive deep into Jmeter timers, covering different types, their configuration, and how to use them effectively to create more realistic and insightful load tests. Why use timers? Realistic load simulation. Timers emulate human behavior, which involves pauses and delays between actions. A server's performance under a constant, aggressive barrage of requests might be different from its performance under more realistic, intermittent load. Improved metrics. By simulating realistic delays, you get more accurate performance metrics like response times, throughput, and error rates. These metrics better reflect how the application will perform for real users. Server optimization. Timers allow you to understand how the server behaves under different load profiles. You can simulate peak and off-peak usage patterns to identify potential bottlenecks and optimize server resources accordingly. Avoid overloading. In extreme scenarios, excessively rapid requests can overload the server and potentially lead to crashes or inaccurate test results. Timers help you control the rate of requests to avoid overwhelming the server. Types of timers in Jmeter. Jmeter offers a variety of timers, each designed for specific delay patterns. Let's explore the most commonly used ones. 1. Constant timer. Functionality. Introduces a fixed delay, in milliseconds, before each request. It's the simplest timer and suitable for consistent, uniform delays. When to use. Simulating users who consistently take the same amount of time to perform a specific action. For example, a delay of 500 milliseconds between clicking a button and the subsequent request. Configuration. Thread group add timer constant timer. Name. Optional, a descriptive name for the timer, example constant delay, 500 ms. Comments. Optional, add comments for documentation. Thread delay, in milliseconds. The fixed delay in milliseconds. Enter the desired delay value, example 500 for a 0.5 second delay. Code example, in Jmeter XML. 2. Gaussian random timer. Functionality. Introduces a delay that follows a Gaussian, normal, distribution. This means the delays will cluster around a central value, the constant delay offset, with a certain degree of variation, deviation. More realistic for simulating user behavior, as response times typically fluctuate. When to use. Simulating delays in scenarios where response times are expected to vary slightly due to factors like network latency, server load, or user behavior. For example, delays between page loads. Configuration. Thread group add timer Gaussian random timer. Name. Optional, a descriptive name, example Gaussian delay, 1000 milliseconds plus 200 milliseconds deviation. Comments. Optional. Constant delay offset, in milliseconds the average delay. This is the center of the Gaussian distribution. Example 1000 for a 1 second average delay. Asterisk deviation, in milliseconds the standard deviation. This controls the amount of variation around the constant delay offset. Larger values create more variation. Example 200. Asterisk understanding deviation asterisk the deviation determines how much the actual delays will deviate from the constant delay offset. A smaller deviation means the delays will be closer to the offset. A larger deviation means they can be significantly shorter or longer. Typically, 68% of the delays will fall within one standard deviation value, of the constant delay offset. Asterisk code example, in Jmeter XML. 3 Uniform random timer asterisk. Asterisk functionality asterisk introduces a delay that is uniformly distributed between two values, the constant delay offset and the random delay maximum. Every delay value within the specified range has an equal probability of being selected. Asterisk when to use asterisk simulating a wide range of delay possibilities with equal probability. Useful when you want to model situations where user behavior is highly unpredictable. Asterisk configuration asterisk. Asterisk thread group dash add dash timer dash uniform random timer. Asterisk name asterisk, optional, example uniform delay, 500 milliseconds max. Asterisk comments asterisk, optional. Asterisk constant delay offset, in milliseconds the minimum delay. The delay will always be at least this long. Example 0 to allow for no delay at the low end. Asterisk random delay maximum, in milliseconds the maximum additional delay. This value will be added to the constant delay offset to determine the maximum possible delay. Example 500, so the actual delays range from 0 to 500 milliseconds. Asterisk code example, in Jmeter XML. 4 Poisson random timer asterisk. Asterisk functionality asterisk introduces delays following a Poisson distribution. The Poisson distribution models the probability of a given number of events occurring in a fixed interval of time or space if these events occur with a known average rate and independently of the time since the last event. It's useful when simulating the frequency of independent events. Asterisk when to use asterisk simulating scenarios where events occur randomly but at a known average rate, like users accessing a specific page at unpredictable intervals. Asterisk configuration asterisk. Asterisk thread group dash add dash timer dash Poisson random timer. Asterisk name asterisk, optional, example Poisson delay, 1000 milliseconds average. Asterisk comments asterisk, optional. Asterisk constant delay offset, in milliseconds represents the average delay between requests. It determines the expected delay based on the Poisson distribution. Example 1000 milliseconds. Asterisk mean value asterisk Jmeter's GUI doesn't directly show mean value. The constant delay offset acts as the mean of the Poisson distribution. Asterisk understanding the Poisson distribution asterisk the Poisson distribution is characterized by its mean, lambda. The higher the mean, the higher the expected delay. Unlike Gaussian or uniform distributions, the Poisson distribution only deals with non-negative integer values, which makes it suitable for modeling the number of occurrences of an event within a time interval, which is why it's less directly intuitive for just modeling delays. Asterisk code example, in Jmeter XML. Asterisk important note on Poisson with random timer range asterisk the random timer range is not directly meaningful for Poisson distribution. The core behavior is dictated by the constant delay offset, which acts as the mean. Setting the random timer range is not typical usage and might not provide the intended statistical behavior. If you require more complex distribution control, consider the JSR223 timer. 5 Constant throughput timer asterisk. Asterisk functionality asterisk regulates the throughput of the test by introducing delays. Unlike the other timers, this timer does not simply add a delay before each request. It dynamically adjusts the delay to achieve the desired number of samples, requests, per unit of time. It's more sophisticated and requires careful configuration. Asterisk when to use asterisk when you need to maintain a specific throughput rate, regardless of the underlying response times or server load. This is useful for simulating real-world traffic patterns or limiting the load on a test environment. Asterisk configuration asterisk. Asterisk thread group dash add dash timer dash constant throughput timer. Asterisk name asterisk, optional, example throughput limit, 100 samples / min. Asterisk comments asterisk, optional. Asterisk target throughput, samples per minute the desired throughput rate in samples, requests, per minute. Enter the target value, example 100. Asterisk calculate throughput based on asterisk. Asterisk this thread only asterisk, default, the timer regulates the throughput of the current thread only. The overall throughput will be multiplied by the number of threads. Asterisk all active threads asterisk the timer regulates the throughput of all active threads in the thread group. The desired throughput is shared among all threads. This is generally what you want. Asterisk all active threads in current thread group asterisk similar to all active threads, but only considers threads within the same thread group as the timer. Asterisk all active threads, shared across all threads. The shared option introduces additional synchronization, so use it carefully. Asterisk important considerations for constant throughput timer asterisk. Asterisk scope asterisk the location of the constant throughput timer within the test plan is crucial. If it's placed directly under the thread group, it applies to all samplers within that thread group. If it's placed under a specific controller, example a transaction controller, it only applies to the samplers within that controller. Asterisk granularity asterisk the timer works on a per minute basis. For short tests, the throughput might fluctuate initially as the timer adjusts. Asterisk thread count asterisk the number of threads you use has a direct impact on the maximum achievable throughput. If you don't have enough threads, the timer might not be able to reach the target throughput. Asterisk sampler response times asterisk if your samplers have very slow response times, the timer might not be able to achieve the desired throughput, even with sufficient threads. The timer's goal is to achieve the specified number of samples per minute. If samples take a long time to complete, the rate will be limited by that performance. Asterisk code example, in Jmeter XML. 6 BSF timer, JSR223 timer, scripting. Asterisk functionality asterisk provides the most flexible way to introduce delays. It allows you to write custom code, using scripting languages like Groovy, Bean Shell, or JavaScript, to calculate the delay. This opens the door to highly complex and dynamic delay patterns based on variables, external data, or custom logic. Since Jmeter 3.1, the JSR223 elements, including the timer, are recommended over BSF elements for better performance. Asterisk when to use asterisk when none of the built-in timers meet your requirements. For example, you might need to calculate delays based on the results of a previous request, a value from a CSV file, or a more intricate statistical distribution. Asterisk configuration asterisk. Asterisk thread group dash add dash timer dash JSR223 timer, or BSF timer if you're using an older Jmeter version. Asterisk name asterisk, optional, example dynamic delay, Groovy script. Asterisk comments asterisk, optional. Asterisk language asterisk select the scripting language you want to use, example groovy. Script write your code to calculate the delay. The script must return an integer value representing the delay in milliseconds. You can use Jmeter's built-in variables and functions within the script, example vars, props, log. Groovy code example, JSR223 timer. Code example, in Jmeter XML. Important considerations for all timers. Scope the placement of the timer determines which samplers it affects. A timer placed directly under a thread group applies to all samplers in that thread group. A timer placed under a controller, example a transaction controller or a loop controller, only applies to the samplers within that controller. Order of execution. Timers are processed before the associated sampler is executed. Jmeter evaluates the timer's delay before sending the request to the server. Multiple timers. You can use multiple timers in a test plan. If multiple timers apply to the same sampler, the delays from all timers are added together to determine the total delay. Variable timers. Timers like Gaussian random timer and uniform random timer introduce variability, making the tests more realistic. However, this also means that the test results can vary slightly between runs. Running the test multiple times and averaging the results is generally recommended. Performance impact of scripting. While the JSR223 timer, or BSF timer, offers maximum flexibility, be mindful that scripting can impact performance, especially with a large number of threads. Optimize your script code for efficiency to minimize the overhead. Caching the script in JSR223 elements, the cache key property, can significantly improve performance by compiling the script only once. Example, building a realistic load test scenario. Let's create a scenario that combines different timers to simulate a user browsing a website. 1 thread group number of threads 100, simulating 100 concurrent users. Ramp up period 10 seconds, users gradually start over 10 seconds. Loop count 10, each user performs the actions 10 times. 2 Sampler 1, homepage request, HTTP request. Get request to the homepage URL, example https://example.com/. Timer 1, Gaussian random timer delay between loading the page, reading it. Constant delay offset, 2000 milliseconds, 2 seconds. Deviation, 500 milliseconds, 0.5 seconds. 3 Sampler 2, click on a product link, HTTP request. Get request to a product page URL, example https://example.com/product/123. Timer 2, uniform random timer simulating time spent browsing product. Constant delay offset, 1000 milliseconds, 1 second. Random delay maximum, 3000 milliseconds, 3 seconds. 4 Sampler 3, add to cart, HTTP request. Post request to an add to cart URL, example https://example.com/cart/add. Timer 3, constant timer short delay before adding to cart. Thread delay, 250 milliseconds, 0.25 seconds. 5 Sampler 4, view cart, HTTP request. Get request to the cart page URL, example https://example.com/cart. Timer 4, Gaussian random timer delay after viewing cart page. Asterisk constant delay offset, 1500 milliseconds, 1.5 seconds. Asterisk deviation, 300 milliseconds, 0.3 seconds. 6 Sampler 5, checkout, HTTP request. Asterisk get request to the checkout page URL, example https://example.com/checkout. Asterisk timer 5, JSR223 timer, groovy, dynamic delay based on user session. This example demonstrates how you can combine different timers to create a more realistic simulation of user behavior. You can further customize the scenario by adding more samplers, controllers, and timers to reflect the specific actions users perform on your website or application. Best practices for using timers. Understand your users. The key to using timers effectively is to understand how real users interact with your application. Analyze user behavior patterns, identify typical delays between actions, and choose the timers that best reflect those patterns. Start simple. Begin with simple timers like the constant timer or Gaussian random timer, and gradually introduce more complex timers as needed. Experiment and iterate. Experiment with different timer configurations to see how they affect your test results. Run the tests multiple times and analyze the results to fine-tune your timer settings. Monitor server load. Pay close attention to server load during the test. Adjust the timer settings and thread count as needed to avoid overloading the server. Document your timer configuration. Document the purpose and configuration of each timer in your test plan to ensure that the tests are reproducible and understandable. Use descriptive names and comments. Use appropriate units. Remember that timer delays are specified in milliseconds. Be careful to use the correct units to avoid unexpected delays. Don't overcomplicate. While timers are essential for realistic load testing, avoid overcomplicating your test plan with too many timers. Focus on the most important delays that significantly impact the performance of your application. Validate your assumptions. Periodically validate your assumptions about user behavior by analyzing real user data. Update your timer configurations as needed to reflect any changes in user behavior. Troubleshooting timers. Incorrect scope. If a timer isn't having the desired effect, check its scope. Make sure it's placed in the correct location within the test plan to affect the intended samplers. Zero delay. If a timer is configured with a zero delay, it will essentially have no effect. Double-check the timer's configuration to ensure that it has a non-zero delay value. Constant throughput timer issues. The constant throughput timer can be tricky to configure. If you're not achieving the desired throughput, check the number of threads, sampler response times, and the calculate throughput based on setting. Scripting errors. If you're using a JSR223 timer, or BSF timer, check the script for errors. Use the Jmeter log to identify any syntax errors or runtime exceptions. Conclusion. Timers are indispensable tools for creating realistic and insightful load tests in Jmeter. By understanding the different types of timers and how to configure them effectively, you can simulate real-world user behavior and gain a more accurate understanding of your application's performance under load. Remember to always document your timer configurations, validate your assumptions, and monitor server load during the test. With careful planning and execution, timers can help you identify potential bottlenecks, optimize server resources, and ensure a positive user experience.